Morning to all. So again, welcome back to one more session of the FDP. So today we will be covering some practical aspects of how to use especially the future practical use of QGIS. So we have with us Kapil. Thank you very much, Abhijit, for being with us today. It's an honor to have you. He's a very experienced professional in the field of GIS, having a vast experience. So we are really privileged to have him with us today. And I hope all the participants will greatly benefit from his lecture and talk. On behalf of the organizing committee of this FDP and on behalf of participants, I welcome you, sir. Thank you very much. So, Abhijit, you can introduce yourself and
Yes. Thank you, Varun, sir. Thank you for giving me an opportunity to present myself before reputed institutions like IIIT, Sri City. Thank you, Dr. Raut, sir, once again. Actually, myself, Abhay Kulkarni. I have some 25 to 30 years of experience in the IT field. Previously, I was working as a Linux system administrator, then database developer, then web developer. And currently, since a few years back, I am working in the field of GIS. GIS is not only the GIS desktop application field like QGIS, but also includes web GIS and remote sensing applications. So when I started working in the field of GIS in say year 2005 to 5, so that was a very infant stage. GIS was a very infant stage as far as masses were concerned. Okay, that is more important as far as masses were concerned, because GIS, as it has starting reaching to the root level, we can say, it was not possible at all at that time. There were various reasons for that. So for explaining each and every reason, I would like to explain you something basic about GIS. Of course, there might be some few sessions in GIS, but I will try to explain thing in line with our main profession, the teaching profession. In past life, I had also worked as a lecturer for a gap of 3 years in power electronics field. My background is an electronics engineer, and I was at that time lecturer in a power electronics field. So I don't believe in presentations as such, because presentations are usually made for events. And as a definition of event, we know that event has some start date and event has some end date. So nobody is sure about what will happen to that content once the event is over. So I don't present my content in terms of presentations, but I deliver the knowledge. I would like to deliver the knowledge in terms of the existing resources, so that the participants should know that those resources, and in their turn, they would multiply their knowledge by visiting the various links on the existing web pages, which I suggest them to. Am I audible to each and everybody? Actually, I'm not getting some idea.
Yeah, you are audible.
Okay. So, as far as GIS is concerned, GIS stands for the Geographic Information System. So, it is basically an information system. But these information systems previously used to be only specific integrated with a geographic knowledge. So it was basically integrated with maps. So when you, once upon a time, say not only a few decades, just when I started working in 2005, GIS and maps were synonyms. So output of a GIS usually was in terms of maps, PDF maps. But now with the advent of various technologies like web technology, and very recently Android technology, so GIS is not confined mainly to the maps, but it has got its existence in a broader range like a geospatial data. Okay, geospatial data, or in latter, what we term use as spatial data infrastructure, SDI. So spatial data infrastructure. So this QGIS, this Android application, the web GIS, etc., is only one of the small parts of this spatial data infrastructure. And spatial data infrastructure, the term SDI encompasses various things in it. So it includes servers, it includes clients, it includes Android devices, it includes databases. It also includes some LDAP servers like from user authentication and authorization, etc. Very previously, it was not the case. The eight output of the GIS system used to be a map only.
Yeah.
So in fact,
sorry to interrupt you.
Yes.
If are you sharing the screen or?
Yes. I'm within the 5 minutes. I will share a wiki page.
Sure. I don't know. Actually, people were asking like if you are presenting something. I mean, you are not sharing. You forgot to share the screen. It's not the case.
No. I'm sharing the screen.
Please go ahead. Please.
Okay. Okay. Just. So if you saw this Wikipedia page. So actually, this Wikipedia is a entry point to each and every feature, knowledge point, the entry point to get more information about what we are totally unaware of. So this geographic information system consists of an integrated computer hardware and software. So basically, in GIS there are 5 components like any other information systems. First is the hardware, second one is the software, third one is the data, fourth one is the people, and fifth one is the methods. So again, I will go to the previous, say in the year 2000. So if you see today, there is no control as far as hardware is concerned in our hands. For example, my machine is say having hard disk in terabytes. So if I go to some computer shop and I will ask him that I don't need this, I need only 64 GB. So he will laugh at me. He will say that Android phone has 128 GB. So that hardware part is over. Actually, hardware is a market-driven thing, and you have to buy the hardware which is prevailing in the market. Most of the GIS systems support existing hardware systems, including QGIS or ArcGIS. Then the real part comes the software part. So why GIS was not penetrated into masses in those days? Because people by and large did not have access to costly GIS software. For example, today, if I want to work in the GIS field, I can just, QGIS is fairly known to everybody now. I will just go to their website, I will download QGIS, I will install QGIS, that's it. And actually, I will start using GIS. So when we say free, QGIS is a free GIS software. It is not only in terms of money, that is the free, but free access. So I have access to many things, which was not the case before. In say year 2000, actually I did not have access to GIS software. That's why GIS was a very much lagging field, and it was costly also, and it is even costly today. If we go to ArcGIS desktop software user licenses per user per desktop, it is not affordable to common people. It is only affordable to companies or big organizations. Third component was the data. That was also very much affecting factor on the spread of GIS, because all the GIS systems are data driven, and if you don't have data or proper data acquisition methods, it's of no use. For example, today we have various satellite imagery available. In those days, the satellite imagery was not available. Today we have through government sources all the census data available, in which we have district boundaries, village boundaries, ULB boundaries, etc. That was not the case in year 2000. So I can say, give you various examples where data is one of the important part. Only topo sheets were available. So as far as access to software and availability of data is more and more. So naturally, the word GIS starts spreading it. For example, why we use MS Office applications like MS Word and MS Excel? Because we have access to that. Most of the users use, say, pirated versions of MS Office, but still, the end user has access to it. Also, end user has access to various documentation available in TOCX format or any format, Excel files, etc., etc. So he will start learning and he will start developing his own ideas, he implementing or putting his own ideas. That was not the case before, but now it is very much easier and possible that people have access to software as well as people have access to lot of free data, so that they can acquire that data, they can use that data, and they can map that data, they can process that data, they can make available to that data through various dissipation, information dissipation methods like WebGIS or Android applications. Fourth is a component is a people. So if we even today just take a review, how many computer training institutes are available for MS Office applications, Office applications, and all those, and how much training institutes are available for GIS? So GIS is specifically taught in either colleges or institutions or in the companies which who are working in the GIS projects. So that was only very affecting time, but fortunately, this is the correct time to enter into the field of GIS because things are more and more favorable now, and in future also they are going to be more and more favorable due to availability of hardware, availability of cheap software or free software, availability of abundant of data, authorized data sources, and again availability of people. So if more and more people started using, say, open source free software like QGIS, naturally there will be available of people in this sector, and naturally companies will it will be attracted by more and more commercial companies. So that was main very preliminary introduction to GIS. Now, as far as this wiki page, this one is very important. They store, image, analyze, edit, output, and visualize geographic data. So, in one way, QGIS can be compared with its desktop counterpart of MS Office, whether it is MS Word, Microsoft Word, or Microsoft Excel. What Microsoft Word does, what is the main function of MS Word? The same things. Microsoft Office enables us to store, to manage, to edit, forget about analyze, to edit, output, the content, actually, which we type in this computer screen. So it mainly a desktop application like MS Word deals with the content. Okay, it is a word formatting application and it deals with the content. Similarly, MS Excel deals with the spreadsheets, statistical calculations, formulas, etc., and it develops its own database. And it also visualizes statistical data. Okay. Similarly, on the similar lines, we can make an assumption that QGIS as a desktop GIS software can be considered as a counterpart of MS Office or MS Excel as far as geospatial technologies are concerned or these spatial databases are concerned. What is Excel? Excel is nothing but a database. Okay. Likewise, what is the QGIS data? It works on the geospatial data, space related to space data, and various attributes attached to it. So, if we consider start thinking in this way, that desktop GIS application is a counterpart of Office application, like any other Office application, things become very much easier to understand. Are you okay? May I request one thing, sir, please? Hello.
Please.
Actually, may I get some reciprocation from side? Because when I'm starting the screen, though, so it is just one-way presentation. Is it fine? Am I going on a proper line?
Yeah, I think so. Audience, please, you can respond. Please interact, engage.
Yes. Yes, sir. Nice presentations.
Okay.
Not a one way, two way.
Okay. So actually, no, GIS is a very large field, a very its scope is tremendous. You see, if at all, if somebody is asked in which field you are doing, so if you just say I'm working in the field of GIS, it is not proper, or it is not adequate, rather, I think, because solutions in forest are different than solutions in agriculture. Solutions in, say, water management or they are different than disaster management. Then remote sensing is at all different technology. So GIS is made up of different components and which are supporting to each other. It is not the case in other IT systems. So for example, MIS is just considered of database, front-end data entry skills and reports. That is done. So whether it is a MIS for forest, MIS for, say, agriculture, MIS for other government systems. So core ideology does not matter. But here, MIS made for forest may be different than MIS made for GIS enabled MIS made for forest, different than GIS enabled MIS for agriculture or any other system. So domain expertise in that particular field is desired, not required, but desired. Actually, I myself also don't have that experience in, say, urban planning or any other thing. But if I get some few links regarding urban planning, I can define urban database system using QGIS very easily. That is my personal experience. So actually, it is not that difficult for GIS to have domain expertise. So it is desired, but not required. Okay, that is one more important thing. Again, so this history and development, we should not go into it. Actually, this GIS software has developed and evolved as a lot. There is one more software called as a GRAS GIS. It was developed by using US Army. But fortunately, QGIS has integrated GRAS into it. And we can use all the GRAS technology, GRAS programs from within QGIS. So QGIS is very much easier in that sense also. Again, in QGIS, in backend databases, we can attach databases like Oracle or PostGIS and GIS enabled database like PostGIS. So we can actually store geospatial data in databases, and that data can be retrieved from other systems, and better MIS can be developed. These are also leaflet, D3.GIS. These are WebGIS systems. So the same database can be deployed for WebGIS. So there is one main central database system. Whether you access it from desktop QGIS or a mobile application or some other systems or from database backend systems, the core spatial database remains the same. And that is the main heart of the spatial data infrastructure, which I told a few times before. So actually, let us stop these theoretical things, and so we'll go to some interesting part like data acquisition. So data acquisition in a couple of minutes. So as far as data acquisition is concerned, as an end user, we cannot acquire all the data because there are some actually fields which to rather acquisition of all the data is not possible and it is pointless. For example, I'm not satisfied with the village boundaries which Census has published. Census India has published. So one fine day I cannot decide myself as a company also. No, I will take a project of all the village mapping of all village boundaries. Okay, so that is useless. So in that case, data acquisition methodology does not use, but rather actually I can use that village boundaries for various analytical purposes. I will also show you one illustration for that. Okay, so there are various data capturing or data acquisition technologies. So primary data capture. So this is very much easier, and more commercial companies have also started giving facilities for this primary data capture. I am 100% sure that all of us use Google Maps or Android application of Google Maps. Is there anybody who have not used Maps Android application before to find out the routes and all those things? I doubt. So Google has facilitated some all the users to post or capture their own data. For example, I am running a hotel. So I can put a name of my hotel, timings, images like menu cards and all those things, and upload it to Google Maps. So if we open Google Maps, apart from the roads, there is a host, lots of data, which has already been captured using taking assistance from the common people. Okay, there are hospitals, there are petrol pumps, there are say other very facilities, beauty parlors, etc., etc. So many things. So this primary data capture cannot be done by one company, or it can be done only for some project. Okay, so I'm working on a Pune city, for example. So its primary data capture is within my limits as a company, because the Pune Municipal Corporation is funding for this project. But if we want to build host of database systems using this private data capture, so many companies like Google, just I explained, have given facilities to build database systems using this private data capture method. So GPS is used. We have also known about GPS to find out the location or remote shortest route between two places. So since the year 2000, or rather I would say 2015, this remotely sensed data is being available. More and more remote sensing data is being available. So prior to that, 2015, there was only one data source, like a Landsat. It was from USGS and NASA, Landsat. So it takes back to year 85, 86, and we are aerial imagery, satellite imagery is available since the year 1985. But in 2015, European Commission started their own space program under the name Copernicus. And these remote sensing images, better quality than in Landsat, are available of a 10-meter resolution. So it captures a cell of, say, 10-meter raster data cell. Actually, I hope I will explain later on what is raster data or vector data. So what I told, that is availability of data. Okay, that is one of the component. So free remote sensing data is getting available. There is again, you might have learned about SRTM data, that height data, elevation data. Especially civil engineers need to deal with it, the elevation data. So we can make an elevation profile of that area. Okay, then we can prepare DEM from that. Actually, in fact, that SRTM data is a DEM data, and we can extract contour lines from that SRTM data. So all this data is very much available, handy, and free of cost. And we can immediately start using that data and prepare our own maps or information system based on that. Then after this, say, primary data, there are second data capture. So this second data is most common method of data creation is digitization. Okay. So if I explain about primary data capture like Google, so this is a personal data capture as far as Google is concerned. Or also rectified imagery by the backdrop, drone imagery, for example. In one of our projects, we take a drone image of a Nashik city and we digitize various layers like roads, like manholes, like chambers, severe chambers, drainage chambers, etc., etc. I will show you that also. And we can capture data and data building, which we say data building. So data building is possible with the term called as digitization. We can also make use of available sources like maps, old maps. So we can convert those old PDF or image maps into GIS-enabled maps or systems through a process called as georeferencing. So with georeferencing, we can convert paper-based maps into a spatially enabled maps. Okay. Then I will not go to this projection, CRS, or that it is very GIS-centric. Raster to vector translation and vector to raster translation. Basically, there are two types of data sources in GIS. First one is a vector data source, and second one is a raster data source. Vector data source consists of three features like point, line, and polygon. Okay. So we can digitize any geographic object on Earth in this one of the three streams or any two of them. For example, I want to find out a map of, prepare a map of all the hospitals in my city. Okay. So I need to build a vector data. So for that, I would need this one of these data capture methods. So there are few options available for me. What I will do, I will go to each and every hospital. I will note down its lat-long coordinates. Okay. I will capture or in a plain paper. Then I will come back to office and I will again actually convert that paper with information into spatial information using a tool like QGIS, and I will get a points of all the hospitals in my city. But it's very hectic methods. I will travel all along the way. Okay, just to capture the lat long of all the hospitals in my city. Now, if I use QGIS and bring a Google satellite imagery on the backdrop of that QGIS, and actually, if I know whether these hospitals are, actually I can point out the hospitals. Okay, and I can prepare a database of hospitals in my city. So I can build data in one of these ways. So I can capture this information in two methods. Actually, I just give a point to that hospital, or I can mark the area covered by that hospital, means boundary or compound wall of that hospital, or say compound wall of a government office, compound wall of a water treatment plant, compound wall of any other district court, etc. So any of these can be pointed, marked as a point, and we can develop a point database, or we can draw the boundary and we can create a polygon database. But as far as roads are concerned, features like roads, rivers, streams, those are line databases. So this is a vector database. Once captured the information, we can attach any information to that particular geo feature in terms of an attribute table. So attribute table is nothing but a table like Excel. In Excel also we have it is a spreadsheet. So all the information is gathered in terms of rows and columns. Okay. So columns represent a uniform type of data, whereas rows are the unique information about those columns. And in this tabular format by rows and columns, we can capture data. Similarly, all the database is captured in terms of the attribute table for that geographical object. For example, hospital, or say hotels, or education institute, anything, government offices, or the overhead reservoirs. So you just imagine anything. So to capture a spatial location or a geometry of that feature is one thing, and to attach useful data is very important, because if there is facility, so attach any data, it's a bad practice. So we should always attach the useful data to that particular hospital. For example, hospitals, how many beds those have, how many ICU beds that hospital has, etc., etc., etc. So we can build that special database. But to collect this information, we again need to go to that hospital, or we can get this data from other sources, and we can build our information. Similarly, it is a road, so we can attach road names, type of road, whether it is a concrete road or a tar road or bitumen road or something road. Does that road have a divider? Yes, no. Does the road have footpath? Yes, no. Likewise. So from better planning perspectives or other perspectives, we can start building databases using this methodology. Okay. Then third is the processing of satellite imagery. Just I explained a few minutes back. If we have SRTM DEM data, digital elevation model data, any civil engineer can extract the contour lines in a couple of minutes, literally in a couple of minutes. He does not need to take the topo sheets, old topo sheets, georeference topo sheets, draw or digitize lines over those topo sheets, attach the elevation value, and prepare a contour map, contour vector map. It is absolutely not needed. You just go to USGS website, register yourself, download the DEM data for your area of interest, and you will get the contour map of all the area, of the whole area, and you can use the area of your choice, of your interest. So these systems are becoming very much predominantly, and people have started accepting those into their regular practices. Then terrain analysis and all those things. It's, as I said, it's very broad and very used technology. Web mapping. Actually, web mapping is also taking means important space in geospatial systems. I would definitely like to explain something about, before going to actually QGIS, I would also like to explain you about this web mapping. So all the data sources, etc., satellite imagery, vagara, it's okay. It's we have done all the things. But how to dissipate this information to the common user? That is also one of the things. I have developed databases, spatial databases using QGIS. Okay. As far as here is the difference. As for example, if I am a journalist, and if I write a press note of say 2 pages using MS Office, I can straight away send that press note in docx format to my editor, sub-editor, or my composer, etc., because I know that the counterpart is also having MS Office installed in his machine. But here it is not the case. I have developed something using QGIS. Okay. And if I want to transfer or dissipate this data to other party, I'm not sure whether he has where he has a QGIS installed on his machine, whether he is a basic user or intermediate user, or what sort of user he is, etc. And most importantly, I cannot insist him. Okay, I have this database in QGIS ready with me. Now you have to install a QGIS, and you have to import that database, and you have to visualize in this particular fashion. So we cannot mandate other people to install QGIS and start only, etc. You know what I mean to say. So in this case, this web mapping comes into picture. So what information I have derived or developed using a desktop GIS, say QGIS, using QGIS. So web mapping is one of the most cheaper way, broader way, and it is a industry standard way, we can say, to dissipate that information using a web technology. So it just needs to integrate our data or convert the data into some formats, or straight away we can, if there is database or data, we can give access to database and prepare a web GIS, and so that web GIS can be opened by any end user who is just having an internet connection and a browser, and he will able to grasp that data through this dissipation of GIS information. So that is the main objective of web mapping, to dissipate the information you have to people. Of course, you can also develop a portal based around this web GIS. For example, in our utility management system, some layers are available to public. Then we have maps, say sewer lines, manholes, sewer chambers, which will be accessible only to the public health department. Then water supply lines, water junctions, supply walls, etc. Those are only available to water supply system, municipal engineer of water supply system. So we can also later build authorization and authentication systems for this web GIS, but that has a very advanced usage. But this Google Maps, OpenStreetMaps, Bing Maps, etc. So these are the popular methodologies that those companies or organizations or institutions have adopted to basically dissipate their information. And this is the applications of GIS. So as I said, applications is a broad scope, very broad scope. In our GIS terminology, there is one popular statement which any GIS professional don't forget, or he should not forget. And that very much popular statement is that 80% of the data, 80% of the whole data in the world has some spatial component in it. Okay, 80% of the whole data have some spatial component of it. For example, as far as your college is concerned, IIIT, so it might be hosting say 1,000 students from all the branch, all the 4 years, etc. So 1,000 years. So these 1,000 years definitely are not from Sri City. They might have come from all corners of the India. So from where they have come? So where the where clause comes, this partial component is comes into picture. As far as I just told about this 80% part. So you can map those. This particular student has say come from Pune, this from anywhere. Then later on you can analyze how many students have come from Pune, how many students can have come from Chennai. You might have Sri City might have all this information in their database, but unless you use GIS, it will not be visually apparent. Okay, your administrative system just give us say Excel sheet of say 2,000 lines and Pune, Mumbai, Chennai, Bangalore, etc., all the cities, and now you analyze yourself. So if anybody interested in cannot analyze the data in terms of this Excel file, but this says suppose this Excel file you see as a attribute table of a GIS system, and you attach this point database to that location. This visually appearing maps become very much easier. So in one layer, you will see all the cities. Okay, these students in Sri City have come from. Later on, you can develop cluster databases on all other things like how many students from Pune, how many students from Maharashtra, how many students from Andhra Pradesh, anything. Likewise, it will give you visually appearing things. Again, then actually this Maharashtra has less penetration of students, etc., as compared to our expectations. So naturally, what we can do, so we can build a decent support system. Same applies to each and every database. For example, banks. Banks has customers. So what is the exact location of that customer? Okay, from address. This is reverse geocoding. We apply a term called as reverse geocoding. We can capture the all information about those clients. Then it will be very much easier for that bank to set up a new branch or set up a new ATM or remove that ATM because we don't have penetration of our clients in this particular area, and this ATM is not giving us business. People from other banks are using it, etc., etc. So bank account holders, as far as systems in 2000 are concerned, so bank account holders was not attached as was not seen as a spatial data, but currently it can be seen as a spatial data. Bank customers, and the bank can get very much insights by processing and analyzing this data. So enormous applications can be built using this GIS technology. So I stopped this Wikipedia sort of introduction, and actually I also purposefully show this Wikipedia wiki page because, as I said, I don't believe in presentation. Because this is also one method of dissipation of information, useful information about the field GIS. So it is also requested that you also go to links, various links this page provides us. For example, economics, politics, transportation, the fields in where GIS can be used, education, wildlife management, sustainable development, climate change, etc. So as I said, 80% of all the data has some sort of spatial component in it. And if we extract or attach that spatial component, so anything can be done in GIS, say urban planning, public health, crime mapping. Okay. So this is a very introduction to GIS. So I have started my QGIS interface. So, sir, is that okay up till? Hello? Hello.
Yeah. Hi. Abhay.
Hello.
Yeah.
Is this fine?
Yeah. That's fine. Perfect. Yeah.
Okay. Now I start using demonstrating them a few databases which we have developed using QGIS. Okay. I will also show you them how to digitize the things basically later on, and how to make use of the existing data that can be imported into QGIS so that a basic information system can be built. Is that fine, my line?
Yeah. Definitely. Please go ahead. You are
Okay.
actually having very well. Please go ahead.
Okay.
Participants, please, please respond so that it will be more of an interactive session. He's so experienced person, so please be responsive so that he will also, sir will also find it interesting.
Yes, definitely.
Thank you.
Thank you, sir. Thank you. So actually, this is the QGIS screen. So in first sight, one may get daunted when he see that screen. अरे भाई ये तो बहुत कुछ complex things है. So I will get back. I don't want to work in GIS वगैरह वगैरह. Actually, we have experienced those reactions of participants, but it is not that thing. Actually, again, I would like to quote some other very much predominant statement. Okay, just that I just quote that 80% spatial data wala. Ki, this is especially we used to deliver in the presentations for layman participants as far as MS Office and MS Excel are concerned. So first of all, when we see MS Excel or MS Word, we have same reaction. अरे बाप रे, बहुत कुछ है. So many formulas, so many things, so many वगैरह, etc. But actually, you also please keep in mind this second term. There are only 10% feature, 10% people who use 90% of the feature of that software. But there are 90% of the people who use only 10% of the features. And we are among those 90% people. Okay. So if we see this menu, this vector and raster and database, etc. So at first sight, we may get some afraid of things. But actually, we are also only going to use only 10% of the features of QGIS. So just forget about the rest 90% features, because we are not among those 10% geeks, we can say, that we are to explain and learn whole QGIS in one session for one day or 1 month even. So it is not the case. So please don't get afraid of these things and just started look at it as a positive way, that we are in those from those 90% people, and we just need to use only 10% of the features of this system and nothing than that. So these vector data, as I explained, all these vector geoprocessing tools like buffer, clip, difference, dissolve, then research tools, data management tools. So these are all this functionality is structured in a various menus, like raster menus, like extraction of contour. This I explained. Flip the raster, then convert into raster to vector, analyze, create a hillside map, etc. So first of all, if you find out the area of application, then I suggest you to concentrate on your area of application only. For example, if you have you are very much interested in remote sensing, so don't look into GIS part, but you concentrate on the remote sensing part. And forget about this vector geoprocessing, all these vector menus and analysis, etc. Because only couple or 2 or 3 will be needed if you are dealing with remote sensing. If you are dealing with, say, capturing of information and preparing a vector database, just don't look at the raster. Forget about all the raster menu. Forget about all the database menu, etc. Forget about all these processing toolbox, which have, say, 3,000 tools. 3,000 tools. 3,000. 3,000. So you don't need to look at this. Okay. So we will first start using a very easier database. For example, I have this database of say Ahmednagar Taluka. My native place is Ahmednagar. It is just 120 kilometers away from Pune. Many of you might, all of you might be knowing Pune. So this Ahmednagar is, and this is a Nagar Taluka. Okay, it's a block, Ahmednagar block. And this white area is represents Ahmednagar city, and this white area is an error in that census file. This is taken from the census data. Okay. So these are the polygon sort of things. If I go to this properties things, okay, I give information about this data from where it is going, what is its extent, what is its projection, this is the CRS, then what is the type, this is the polygon. I said earlier, no, this vector data can be represented in only three formats: point, line, and polygon. Feature count 105. So there are 105 villages, where 105 villages in this particular block. Okay. So this is the spatial information about my taluka. Now I want to add a Google satellite image on the backdrop of QGIS. So it is not possible with QGIS as a plain vanilla system. Okay. If you install QGIS, so as it is, vanilla installation, you cannot import QGIS various base maps like a Google satellite image into QGIS. There are methods, but QGIS has a very broad and very useful and very vast plugin systems. Plugin system. So it's plugin architecture. So what is a plugin? So plugin is that piece of software which enhances the core software without affecting its functionality. So plugin is a piece of software which enhances the capability or capacity of the existing software without affecting it. So if I install any plugin, core functionality of QGIS didn't get affected. Or if I remove say several plugins or all plugins, again core functionality of QGIS will never going to be affected. But if I install the plugins of which are useful to me, core functionality of QGIS is enhanced now. So I have to bring the Google map on the backdrop. I install this plugin, this quick map services. You may note down it, quick map services. I go to plugins, then manage and install plugin. So it will give a list of all the plugins, and this is the list of all installed plugins. So it has update. So it is showing in the bold. And if I click all, there are 1011 plugins available in this plugin architecture. So this quick map service I have installed and enabled. Okay. So I will just go to web quick map services, Google, and say Google hybrid. And all these Google blocks or villages are visible on the backdrop of Google satellite image. But I cannot see what is beneath. For this, I will need, for each and every time, I will need to show and hide this layer. So I will make use of an inbuilt symbology feature. So I will again go to properties, symbology, simple fill. So instead of simple fill, I will select simple line. And instead of black line, I will select say yellow line. And I will increase this stroke width. Okay. Then all the villages are seen. So I will go, if I go to this Nimgao Vaga and all those things villages. So I have a village boundary database which has been authorized by Census India with me.
Yeah, sorry to interrupt. I think, can you share the screen? I think you are not sharing the screen. If you.
Oh, sorry. Oh, sorry. I forgot that. I'm extremely sorry. In that flow, no?
No problem. Yeah.
Thanks a lot for reminding me. Oh, okay. Now it's not visible.
Yeah, it's visible now.
So sorry. So these are all the village polygons, and these are all village boundaries. Okay. So this is the information provided by Census India, which I have imported into QGIS. Now it's up to me how to use this information. Okay. Now I am working for a Zilla Parishad, and I want to know all the number of schools or primary schools in my per village. So I can attach that information to this particular field. I will show you how easy it is. The Anganwadi, suppose I want to attach the number of Anganwadis in this particular school or projects, or likewise any other informations. So I can build and enhance my database. So as it is given provided with this attribute table. So this JML ID, state name, district name, GP name itself, block name, IP name, block name, census code, etc., village name, village code, and this is a total area and area irrigated, which two columns I have attached only for public demonstration. Okay, total area of that village and area irrigated in that village. Likewise, we can attach any information. I will just show you one example. So first of all, how to make use of it? That is very interesting, and we can prepare a basic map out of it. Okay. I will again go to this attribute table. Now I have three columns apart from the census data. These two columns were in the census data, and this percent irrigations. So I have total area of my village. Okay, total area. Then I have area irrigated, and now I want to calculate the percentage of irrigated area in that particular village. So how much irrigation functionality or irrigation is penetrated into villages. So for that, I will use this total area and area irrigations. So I hope this you will find resemblance with MS Excel. In MS Excel, if you want to find MS Excel, find out this MS Excel, what is the percentage area? So can anybody tell me how to find out the percentage area in MS Excel using these two columns? I'm forget about GIS part. Now we are dealing with MS Excel. So in MS Excel, we have only say this spreadsheet, okay, and there is one column. We will just click on that column, and we will attach a formula to it. Is equal to into bracket area irrigated into 100 divided by total area. That is our formula, no? So likewise, we can also apply formula here. So suppose I will go to this field calculator, create a new field. Say I have already created it, percentage, PRCTG. It's very...
Yeah, sorry to interrupt again. I think we can only see your QGIS screen that with that map displayed. We cannot see the attribute table.
You can, okay, but I was once again, I have started sharing all this entire screen now.
Yeah. You can see that.
No, I have selected entire screen. Okay. Now can you see?
Can you open the attribute table?
Yes, I have opened attribute table once again. Can you see now?
No, not yet.
I have shared the entire screen. Yeah, 1 minute again.
Can you share the text also?
Yes, I have shared the entire screen. Now?
Yeah, you can. Yeah, you can. Now click on. Now it is. Yeah.
Is it seen attribute table?
Yeah.
Okay. So this is the total area, and this is the irrigated area. Okay. And I want to calculate the percentage area. So in Excel, it is very much easy. I will just go to this cell is equal to into column area irrigated into, I will apply the formula. Similarly, we can apply formula here and create a new field. So it's very much easy. It's a field calculator. Create a new field, say PRCTG, then decimal, and again apply the formula, fields and values. I am just running it, just show the functionality. So area irrigated into 100 divided by total area. And I will just click OK. And this new PRCTG field is appearing here. So what I have done, what I have calculated percentage of irrigated area for that village, this Khadki village, Matne village, etc., etc. And I had these two values with me, authorized from Census India website. Now, how I can make use of it? How I can make use of it? So I will again come to this attribute table. I will go to, I will just illustrating, I just take it as a functionality, symbology. Now I have selected single symbol. So I will select instead graduated. And I will select PRCTG. And I will select classify. And I will select OK. So I got classified image. But there was one mistake from my side, because I had, instead of symbol line, simple field. You might think it's a fast, but actually this is the case. So this villages in white have 4 to 39% of irrigation, and red are 78 to 100% irrigation. Now it is again the against the symbology. Means the villages which have more 100% irrigation, we are showing in red. So we can change it. Say properties again. And these are values, and this is legend. So we can have our own values. So low value is 3.63, and I can give it to, say, 50. Okay. And again 50 to 60. Okay. $60 to 70. Okay. 70 to 80. Okay. And 80 to 100, we'll keep adding it. Now for this, we will have, say, this green color. Okay. For this, we will have another shade of green color. This one. Okay. For this, we will have some, say, orange color. Okay. We will have this color. And for this, we will have red color. Okay. Okay. Now, in one glance, I'm able to find out about these villages. Which are the villages which have 80% of 80 to 100 villages. But again, if I know this map, it is easy for me. But if I am being transferred as a CEO, suppose, but I don't know which one is village, so we can apply labels. Again, we will go to properties. I will go to labels. I will single label. Then village name. Then this text. I will apply this text as this color. I will make buffer. I will apply buffer value as this one. Okay. So now I will get the village name of all these things. So this village Sandway has irrigation between 80 to 100%. But what are these red villages? So now I will start thinking why these red villages have irrigation in the range of 4 to 50, below 50. What might be the reasons? So if as a CEO or a decision-making officer, if only Excel files are presented, so he can do inference from the discrepancy in a very limited manner. But if some sort of GIS system like QGIS has been given to him. So with a basic knowledge, this is very basic knowledge. With a very basic knowledge, one can do all this sort of analysis. That's why in my earlier 5 minutes, I told that in our day-to-day usage also, we should start or viewing QGIS as a desktop application system like any other desktop office application. And I am quite confident within next 10 years, this QGIS people will be using QGIS like they use MS Office today, MS Word or MS Excel, at least in organizations, government organizations, institutions, etc., etc. I am 100% sure that within next 10 years, QGIS or any other application like QGIS, if it is there a better one, it will be adopted in the mainstream as a desktop application. Due to this various ease of access of software, ease of access of data, and more about ease of access to people also. It's a human power, which actually, if you go to say, for example, any Jilla Parishad office, you will not find this GIS user. But any within a 1 month training programs, Jilla Parishad can host this conduct training programs in QGIS, and they will have a pool of trained personnel as far as GIS is concerned. So this is a very basic application. So what I have done with this existing data. Now I will come to another part. For example, it will be a basic application, but this is in edit mode. Now I would like to attach, okay, a new Anganwadi suppose field. So I will create a new field from here. I will, Anganwadi, no? Yeah, in Andhra there is some another word for it. So it is an integer, number of Anganwadis, suppose. Okay. By default, it is null. Okay, now I will again close this and I will again come to this particular thing. I will go to information and I will go to this, say, village Khare Garjune. Now I will see here null. So I will again go to this form table. I will start, say, it is only 2 Anganwadis. Okay. Then this Nimgaon. This is, say, 1 Anganwadi. Okay. And likewise, we can start building databases. Now, if I go to again to attribute table, here there might be 1 Anganwadi, 2 Anganwadis. So what we are doing here, we are using here like a MS Access like system. Okay. Whereas in Access, it is a provision that we can fill data entry forms. We can have data entry using MS Access, which builds a database, Access database, as well as a Excel file. So here we are doing the same. Okay. So likewise, we can acquire information about the number of Anganwadis in a very, say, 1 day or 2 days. We just need to telephone that Gram Sevak or WhatsApp पे डाल दो कितना है, and it's just WhatsApp पे जो data आएगा, you just have a data entry, and all these useful database can be built. Again, I say currently all the ZP or any government system or other, they have these databases, but this database is in Excel files, which are very much harder to visualize and analyze. So QGIS in this case is a assisting a helper application which presents the data in a very useful manner in terms of maps or in terms of chloroplast maps like this. So this is a very basic application. Okay. So I will close this application. Is this fine with you?
Yeah, it's perfect. Thank you.
Okay. Okay. So likewise, we have created a large, very number of projects depending upon their criteria. This is our latest project. So this is for that urban planning or utility capturing systems, and it has 40 layers. So we have captured information about roads, urban land use, then building footprints, encroachments, water supply network, then say sewerage network. So as far as sewerage network is concerned, all manholes, SWC, sewerage chamber, etc., etc., etc. So by default, I have made all this invisible, hidden. But for example, these are slums, open lands, road polygons, etc., etc. So we have captured this huge information. But again, so though there are some 45 layers of information and huge spatial database we have created, still that my sentence that 90% and 10% wala. This is only a 90% people wide job, because though the information is enormous, for example, these building footprints, building footprints. We have 27,000 building footprints like this, each and every building footprint. So the scope of work is enormous, but it is not that advanced, or that is what we say precise use of or advanced usage of those 10% people. It still represents the work done of a 90% people or a group. Means scope is vast, but technology deployed is not that important or not that advanced. It is only 10% features of QGIS we have used for this. Okay. So suppose this is sewerage network. So in this sewerage lines, we have captured this sewerage line using a technology called as GPR. Means actually it penetrates the underground pipelines and creates a map of these underground utility maps. So these are the manholes or chambers. Okay. And we have built this database and integrated all this data into QGIS. So this is a sewage network of our project city. Likewise, we have stormwater drainage network. So these are the natural drains. Only 3 of them are remaining. And these urban people have lost many streams, and ad hoc construction activities had been seen, but that is another topic. For example, this is the drain chambers. Okay. And this is the main drainage line. And all these drains are connected like here. It's still the work in progress. So it is very much easier for the municipal engineers and other people dealing with this to have all these database with them, because this is the case in each and every city, Indian city, or many cities throughout the world, because nobody knows what pipelines or underground utilities are there, because वो अंग्रेजों के जमाने से है. It is before many of the pipelines and all those things are pre-independence era. And no, this ULB people, corporations and all those things, they don't have proper maps. They have torn maps. They are not unclear maps. Maps are not to the scale even. So it is very much hurdle. So we have built all this database using these advanced technologies, and we have imported all this data into this particular project. So for example, I need some municipal engineer needs work here. So he will make all the layers on. Okay. And in one glance, you will be able to see, okay, from here water pipelines are going. Here are the underground electricity lines. Here are the drain lines. Here is the sewerage line. Normally what happens, no, the JCB wala aata hai and just put JCB just anywhere here. And when it lifts that, so it comes up with a host of bunch of wires, BSNL wires, cables, pipelines, etc., etc. So this is also headache of municipal engineers. Now, if they have all these maps available with them, okay, all this is the main choke, and these many underground utilities are there, water pipelines, utility lines, then drainage lines, sewage lines, etc. So actually, the municipal engineers also cannot judge from where to start the work, actually, where to put that JCB and excavation works and other works, etc. If now footpath needs to be built, so in advance we come to know that okay, here are the drainage lines and water pipelines. So what is the, say, depth? Okay. So this is a sewage line, suppose. So 0.9 meter. So just 0.9 meter below lie a sewage line. Just 0.6 meter below lie a drainage line. Just again 0.6 meter below lies a water pipeline, etc., etc. So that was the main purpose of this project, to capture all the underground and subsurface utilities. Okay, and to create and prepare a map. So this is the one of the major projects that we are carrying out. So this is the geospatial information. So I have just yesterday I gave a 2 hours lecture on this whole system, but actually we don't have that time. So I will close this demo. So is it fine, or anybody want to ask something? Any queries from your side regarding this system? Please ask.
Participants, if any queries, please.
There is again one more interesting map we have prepared. And actually, it will be very much interesting for the civil engineers. Okay, if they are attending this session, and that is a DTM. So this is a drone image we have captured. Okay, it is very high resolution drone image. So this is the basketball ground. This is a car. So even you can measure a length. Okay, here, length of a car. So it's 3.88, sub 4 meter car. Maruti Desire, वगैरह, I think. But actually, we can attain such accuracy. That's what I want to point out. We can calculate the exact length of the car using this high resolution drone imagery, and we have just created a road network. For example, say this is the road. Okay. Now we have already created a road. I will show you it on a plain Manila system instead of a drone image. But taking this drone image while a drone survey, okay, we also captured the elevation value of millions of points. Just imagine, we captured elevation information about millions of points, which is known as a point data cloud. And the GIS software processes that point data cloud and creates this high resolution image. And it also creates the elevation part. And using that elevation part, we create a DTM, means digital Tarai model. So this is the digital Tarai model of the Nashik city for that particular 10 square kilometer of ABD area. So this is the river. For example, I make this layer on. So this is the river. I can superimpose this vector data on this raster image of DTM. And now I clearly see. So here, this is the Godavari River, here are the bridges and all those things, and various elevations on this DTM. For example, what is the elevation at this point? So 580 meters. This point 587 meters. Riverbed 562. Bridge 571. This is the lower bridge, say 566. Again here 585. Likewise, we can have all the elevation values attached to each and every cell of this raster image. We then prepared a hillshade map. So this is the hillshade map. So depending on that DTM and elevation values, so here is one stadium is clearly seen. Okay. For example, this is a stadium, and this is the sitting arrangements of that stadium. So we can capture all this information in detail. Okay. So there is a garden and all those things. What are these things? This is things. This architecture in Nehru Gardens area. So all this information is captured, but it's okay for the point of interest. Okay, yaar, bahut acha lagta hai. It's very beautiful. It's a hillshade image. What is the exactly use of this hillshade image? So now what I will do, I will superimpose that DTM, and in other function of a raster image, I will reduce its transparency, say 54. Now I have two raster layers, hillshade map and DTM map. Now I will get very much clear view of this particular thing. Okay, so all these stadium things and all those things. But how, again, how I can use it for my own purpose? Now I have this, say, building footprint database with me. Now if I zoom in to this particular area, okay, so from this DTM and hillshade map, it is quite evident for me that this is the flood prone area. This much is the flood prone area. This much is the flood prone area. Flood water may get inside. Okay. Now these are the buildings which have threats. These particular buildings are okay. Okay. But these buildings have more threat than any other buildings in this area. So this is the inference I had drawn by visualizing. If a municipal commissioner is presented with, say, 28,000 rows spreadsheet having all this building data and elevation data, for example, all this building data, ye area, ye kya. So can any municipal commissioner or respective authority can draw inference which building is under threat when there will be a flooding in the Godavari River? It is not possible just by mere looking at Excel file. But if we build geospatial databases like this, like drone mapping, like DTM map, like DEM map, like building footprint map, now in again we can attach various information to this building. How old is building? Ye purana wada hai ya recent structure? How many families are living in this building? So we are just away calculate that so many families or so many people are under threat. If there is a heavy rain in the Godavari River and water just started rising in this particular area. Yes, Chennai flood, we all know. Actually, very classic example. We should not say like this, but it was a classic example. So how flood management systems can be derived or built using all this information. So this is the one typical use case of this DTM map and map. It also again can be superimposed on Google image. So here we just quick visualization. Okay, this DTM map, we have reduced the transparency level, but this drone image is 100%. So we can superimpose that map, and we don't need to digitize buildings and all those things. That might be a latter part. But at a first-hand site report, just sitting in the office, I can draw conclusion that this particular area is low-lying area and something needs to be done. Okay, if I represent the fire brigade department, fire brigade, so I clearly see through these narrow lanes and all those things, fire brigade vehicle or that tank vehicle cannot just pass. So these buildings are under threat as far as fire is concerned. So what is my evacuation map? So for evacuation map, I will draw some other databases. I will. So like it is very, means you can do anything as far as things are concerned because you have access to data, you have access to software, you have access to people if they can build database systems. That's what I want to point out. So again, I said 80% of the data has some spatial components. So as far as the firefighting systems or fire brigade department of say that municipal corporation. So in the case year 2000, it was not considered as spatial data, but now it can be considered the spatial data. We can plot fire brigade stations. We can plot hospitals. If there is a big fire in that Purana systems and all those things, fire broke up. So what are the nearby hospitals? What is the patient carrying capacity of those hospitals? So this particular buildings, say 580 buildings comprised of say 3,000 people, but the beds are only available to 1,000 beds. So what is the provision for next 2,000 people? So in disaster management systems and all these integrated systems, again in the next 10 years, these desktop GIS are going to play a part of a office application. Just now, we use MS Office, MS Word, and MS Excel in our day-to-day use. At least government agencies and the concerned departments, they will use this desktop GIS systems as their day-to-day desktop office applications sort of things. So this is the one more database, that encroachment. Suppose we have found out the encroachment on the system. For example, this is the drone image, and we have digitized this drone boundary. So digitization is very simple. For example, I say that this is the slum. To me, it is not a slum. We should not. We should respect their feelings, but still. Oh, sorry, I digitized this slum. So, for example, say this is a slum packet, for example. Okay. So I have developed a slum database. Now I come across one more packet. So it's very easy. Just I will go to edit mode. I will start click this create polygon, and I will just draw the boundary. I'll just draw ad hoc boundary because this is demonstration. Please, it's not final. Then it will give me to fill this information. What is the slum point ID, class, subclass, ward number, road number, वगैरह वगैरह वगैरह, and I will click OK. A new slum is developed. The new slum boundary has been developed. So likewise, it's very much easier to build data if you have some bedrock map or base map available with you. So naturally, this is a high resolution drone image, but nobody can possess this high resolution drone image, but want to develop some sort of system. So always this option is, and this option will be always available to them. This is the Google map, for example. And I just demonstrated how to import a Google map using this plugin, Quick Map Service. So you can start developing your own database here. For example, I will Narayani Hospital. I will start to plot hospitals in Nasik, say. So I will just here it is not a layer available, but I will just create a layer. Say layer, create layer, new, say temporary sketch layer. This point, this ID. Okay, then name, MT. Okay. So it's I'm just collecting the ID and name of the hospitals. Okay. Now I will go to digitize mode. This one. Oh, sorry, that name field is not added. ID 1, name Indrayani Hospital. Okay. So you can see the point here. And this point information is added. If you go to the attribute table of this point, so it has only one record, one number and Indrayani Hospital. Okay. So likewise, Shraddha Medical and General Store. Where is the plus sign? Hospital. COVID Center. Okay. This is 2, name COVID Center. Okay. Again, if I go to attribute table, this entry in Excel file sort of structure has been added. So likewise, it is very much easier for you. Okay, I will discard this layer because it's from the main production system. So it is very much easier to build a hospital database system using the existing data. Okay. Now I will come. I will show you some other interesting part. For this, I will close this project. Okay. So it is a very good idea. I myself am using and working in the field of open source systems since year 98. Okay. So it is the one main what we will say philosophy of open source and free software, that whether it is a software, whether it is a code, piece of code, whether it is a piece of information, etc., you don't start from scratch. Okay, you don't start from scratch, but instead first you see whether that information is easily available to you, use that information, and then fill the remaining information if possible, if you are not satisfied with it. So for example, if I have to digitize all the hospitals in this manner, so I will need to, first of all, there are, as I said, I need to go to each and every location, start the lat long, capture the lat long, and build this data. Or preliminary, I can prepare a preliminary database using Google Image or other sources available with me. As far as Google is concerned, Google data is only available freely to view and access. Okay. Google database is only available to common people to view and access. You cannot download the data given in the Google website. You can view it, you can see it, you can view it, you can access that data, but you cannot download that data and use that data because it works on different crowdsourcing platforms. You can only download the data which you have uploaded to Google Maps. When you upload your piece of spatial data to Google, then only you can download the data or you can share the data. For example, you have a team of say 50 professors in IIIT, and they want to map all the particular region, etc. And if they use Google Maps, and if a particular area is given to in jurisdiction of the one professor, faculty, so one faculty uses Google tools and upload the data to Google Maps. Likewise, all the remaining 49 faculties. As far as it is, you have to use the data. You need to download the data for you and consolidate or integrate that data. But the faculty number 1 can only download data which he have uploaded, and he had to share that data rest of the 49 faculty. And this step must be repeated for all the 50 faculty. So it's a very tedious task. So to capture my piece of information and to share that piece of information with the rest of the 14 people, and then download all the data and then integrate that data into Google. So Google is not the correct platform if we want to deploy or import data. It's very great platform to view and access data. So there is one more resource field like a Wikimedia, that is a OpenStreetMap. So are you aware of OpenStreetMap? OpenStreetMap is a common integrated database of the world, which is free to download. So this is the main difference between OpenStreetMaps and Google. In Google, you cannot download the data. In OpenStreetMap, you can download the data and use the data in your own project. For example, take the last example of our hospitals. Okay. Now, this is my hometown, Pune. And I have these many hospitals appearing on the backdrop. So, actually, if I want to use QGIS, okay, then it's very easy for me. Again, I will recall the last screen, say, for example. And here instead, I will use OSM standard. Now, my task is very much easier because I don't need to search the data, because this hospital data is easily available with me. And if I create a layer, say create layer again, temporary scratch layer, this point, etc., and ID, name. Okay, it's very much easier for me because I just go to this and I will find out this hospital. I will click here. I will this number 1, that hospital name, P hospital, etc. I will again go to this hospital, Sahyadri hospital, etc., etc. So my task is very much reduced now because I have this easy to use hospital database available with me. But a technocrat is the most unsatisfactory creature in this world. Okay. And engineers are more than that. So they started thinking, see, okay, it is database available with me. So is there any mechanism so that all the database will be available to me instead of digitizing or pinpointing each and every hospital, write its name, etc., etc., etc. So I know that 100% it is not possible with the Google Maps. But is it possible we at least using OpenStreetMap? Then yes, it is possible. Now I will demonstrate how to download this hospital data. Okay, it's very easy. It's very easy. Once you know it, how to download data. For this, again, there is a plugin called as Quick OSM. Okay, I will go to this Quick OSM plugin. And OSM data is structured with keys and values. So it's very, there are thousands of keys and again hundreds of keys and thousands of values. But the key we use is amenity. When you select this amenity, you can have access to all these center, bank, then bicycle renter, bicycle parking, say bus station, brothel, the cinema hall, multiplex, then doctors, fast food centers. If anybody have uploaded or digitized this information into OSM, likewise here is a hospital, police station, prison, shelter. So hundreds and thousands of data is categorized in. So I will select hospital. In around canvas extent, layer extent, no social. So it is canvas extent. So it will capture all this canvas area, means area visible to me. Okay, and I will just click this run query, and within a few seconds, all this database is available with me. Okay, just see how fast I have access to hardware because it is available. Is it available with me? I have access to software. I have access to QGIS. I have access to this plugin called as QGIS. How easily I have access to data because this OpenStreetMap, all the data is uploaded and categorized. Okay. As far as people is concerned, okay, I'm a QGIS user. And the method, the most important thing is the method. Forget about hardware, software, data, people, etc., etc. But you don't know the quickest methodology. Okay. आपको मालूम ही नहीं है कि कैसे करना है, suppose. And you can, we don't literally take it the meaning, but most of the time we do donkey work. Just I know this how to build database. Okay, I will just start it pointing. It will take a whole 2 days for mapping all the hospitals in Pune. But if I apply the proper methodology, so it's even 20 seconds job that I have hospital database at my desktop. Okay, it is the case that it is not complete. It may not be complete. I don't claim that it is complete. But otherwise, if I again apply some other methodology, so in very minimum point of time, I can capture rest of the hospitals in Pune, say within 2 days, by visually inspecting those websites. Inspecting those hospital sites. Okay, now I will again take a help of, say, Google. So this Google hybrid map is loaded, and this Google standard, I unhided this OpenStreetMap. Now if I had to go there, this is the Google map of the corresponding. I will change its color. So these are the hospitals. Hospital. So this information you cannot download from Google. I can see hospital here, suppose. Okay, I see hospital here. But I cannot download this data from Google, Moria General Hospital. I want to view it, see it, have access to it, but I cannot download. But using OpenStreetMap, I can download this data. So I have all this data available with me. So if I click here, 176 hospitals. So in 20 seconds of time, with me, I have database of 176 hospitals with all these names and all those things. Sardar Patel, Gowlekar, Galaxy Care, Ranka, Bide, etc. etc. Okay. So doesn't sound interesting? Now again, here there are some, you see some polygons. Let me see what this polygon is. So this is a Diranath Mangeshkar Hospital in Pune. So it is old building, it is new building. It is mapped improperly. So what I will do, I will just click one spot here. One spot here, center point. and this is the area. So I said ki any geographic feature can be digitized in point, line, or polygon format. So hospitals, they have digitized in two formats, like a point and polygon. So this is a polygon, these are the points. Okay. So likewise, using this OpenStreetMap, you can also download the streets of your city. Now, if we go to Sri City somewhere here, no? Is that fine? Or
Yeah.
I'm not able to find out IIIT because we cannot search from here. For search, I need to go to Google website, but it is somewhere here only because I have just ये अभी था ना. This is IIIT, right? But it has not presence. This has presence. Somebody might have digitized on behalf of you. So this Indian Institute of Transformation University City. So butterfly park, mango grove, then volleyball court, basketball court, then mess, hostels, I think, canteen. So somebody have digitized this particular thing. Actually, it is also possible to know who has done what things. Doing something. It is Bangalore. अरे ये तो था ना अभी. No, I again lost that. Okay. Now, if I go to this information tool, query features. So all these unknown GRYPHUS. This is a particular person who have done this job for you. It is easily available from here. This is Ankit Reddy, a person called as Ankit Reddy, have digitized this basketball court. Then say canteen. Again, Ankit Reddy. So Mr. Ankit Reddy might have digitized the rest of the things. It seems to be. So likewise, anybody can publish this on the similar lines of a Google Maps. But the only difference is that when you publish your data in Google Maps, Google just makes you available that data to see, view, or access, but not to download. And Google earns money from your work. All these Swiggy, Zomato guys, and all those things, Ola, Uber, वगैरह वगैरह, they use Google Maps, and they need to pay Google Maps for each and every click. And Google earns money from your work, rather our work. But as far as OpenStreetMap is concerned, we can use that data for ourselves also, means naturally, but we can make this data available to each and every user in the world. So it is a more noble cause than Google Maps. Okay. So that was the reason that I was able to download the hospitals from Pune in 20 seconds. But if the users who uploaded that hospital dataset into OpenStreetMap rather would have uploaded that data into Google Maps, then nobody in the world could have downloaded that hospital data and use it in their own projects or own work. Even you can, not you means anybody can also earn money by selling these maps, which have been developed using OpenStreetMap. That is a different thing. So that was one small demonstration about OpenStreetMap. So one small project. Now I will show one classic utilization of QGIS and other things into using remote sensing. Okay. But you just please give me some time. Okay. So a few in past year also itself, we carried out one project. Okay. And the project was that capturing of all the water bodies of the Nasik district. Nasik is one of the biggest district in Maharashtra, having 2,000 villages. It has 15 to 16 blocks and 2,000 villages. And it's very rich district due to widespread irrigation and what we call fruits and vegetables and horticulture, floriculture, and sugarcane plantations, and the world famous grapes, Nashik grapes. So the idea was, or the project was, to capture each and every water body using advanced technologies. Now, at present, I have only this database available with me. If I need to build a database from scratch, because nobody, only portals like IIITS or Government of India has only bigger dams to their credit. But what about the farm ponds, other small water harvesting structures and all those things? So those are still not mapped. Okay. Only bigger dams like this one or this one, which you can see, those are mapped, and those also data is freely available from government websites. So the objective of the project was to capture all the water sources, however small or big it may be, right from a water source like a farm pond or water body like a big dam. So actually, if this is the database, Google set the image. Now, if I zoom into image, I can see this as a farm pond. Okay, this farm pond, this farm pond. Now I will go to this rudimentary जो method जो है. So I will create a layer in point format, and I will just give you ID, add to field list, and okay. Now what I will go here, click here, 1, okay, 2, okay, 3, okay. Now you just imagine if I follow this method, the fifth component in GIS method, if I follow this method, which is very primary method, so how much time it will take to cover all this Nasik district? It will take months. How many people I will have to deploy for that? It comes under the component people. So I may need a 10 people team. I may need a 11 supervisor to supervise that team. Again, I will need one project manager to supervise all the things, to carry out all the things. So at least I will need 12 people, a team of 12 people. Not only that, I will need 12 hardware components like 12 laptops or 12 PCs. I will need to install QGIS on 12 computers. I will need 12 power connections. I may need some AC or something functionality, tables, chairs, etc., 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 etc. So you just imagine how methodology matters. Okay. So to capture all these farm ponds and the water body, farm ponds is okay. Now, if it is a water body, then I will need to digitize this water body. So it will again take vast amount of time. Too much time to digitize all the water body. Suppose this is complex structure of a water body. Just imagine how much time it will take to capture the water body boundary of this polygon. Okay. So detailing is not needed, but somewhat we need to show. No? What I mean to say, it's a very tedious task to capture all the data in this fashion. So it was mandatory for us to find out some different methodology. So what is that methodology? So this methodology is a open remote sensing. So we use remote sensing methodologies. I will not show all the steps and all those things, but first we downloaded this satellite imagery and processed that satellite imagery. Okay. Now satellite imagery, if we want to have a Nasik district, satellite imagery doesn't come to us as a Nasik district boundary, but it comes into various cells of 1 degree by 1 degree. 1 degree means 110 kilometer. Okay, 1 degree amounts to 110 kilometers. So this one satellite imagery tile, you can say is a tile. One satellite imagery tile covers an area of 110 kilometers by 110 kilometers. So we need to download the satellite imagery tiles accordingly. Then we process that satellite imagery and it was converted into this format. Again, we apply some more processing and it comes into this format. Okay. Again, we have some processing and it was converted into this format. Now it is somewhat clear to us as a visual, but this is a raster data, mind well, and it can only be downloaded. So this was the image taken on say 15th of November when all the dams were full. So this was the latest boundary of those water bodies. In summertime, in April, month of April or May, it will shrink. The boundary will shrink. but clearly we can see the water body boundaries, this river and all these farm ponds. So, but we cannot use this data as it is. If we deliver this tile to customer, और उनको बोल देंगे कि this is our deliverable, you just find it and release our money, तो वो मानेंगे नहीं, they will go send will back, नहीं हमको ऐसा डाटा नहीं चाहिए. So what data we want? So I will again go to them, sir, do you want like this? So each and every farm pond is clearly seen and all those things. बोले तो ये raster data है, this is raster data, which we cannot superimpose that data and Google image and verify whether it is a farm pond below it. अब ये farm pond suppose है, so I will need to go to and find out the farm pond. Okay, this is the farm pond, this is the farm pond. So we'll need to exercise this image. It is hectic time for us. Then again we went to them. So okay, then is this fine with you? So he told, yeah, it is all this bloody violet background. Again, further processing is needed. And this is the further processing. So this is the final database which we delivered to the client. Okay, now we can import this database on the backdrop of Google image. And this is the boundary captured. So somewhere you will not get exact boundary because it depends upon the power level and other things. But actually, it ensures that there is a farm pond. Now these are two different farm ponds separated by a thin wall or something, but it shows a one single. Never mind. There exists a farm pond. So this is the objective of remote sensing. So in a very few time, we would able to capture the information about 11,984, means up to 12,000 of farm ponds. So just imagine in traditional methodology, if we would have applied, it would have some team of 12 people, 12 hardware, 12 software sets, table, chairs, and all those things, etc., etc. And it would have amounted to huge project cost. Okay, but we deployed remote sensing technology. We also got a river boundary, it is backwater of a dam and all those things. And we would able to demark each and every farm pond and water body. Again, this several times we have different processings on these data sets. And finally, we came up with the whole Nasik district as a whole. Okay. So that is one of the interesting part of this remote sensing technology, which we applied into live project. But again, I take you to one more issue which I raised myself. Excuse me for a couple of seconds. Now I developed this database into a native format called shape files or KML files or GeoJSON files. You might have heard a new name of few shape files at least. It is a de facto standard of storing the vector data. So all the information about these farm ponds or water bodies, etc., are stored in shape files or KML files. KML files, well, we can open in Google Earth, but shapefile is a de facto standard. Now, if my client, if he is a government officer, he needs to visualize this data, then I may mandate him to install QGIS on his desktop. So the software part comes again. Okay. QGIS is no doubt is a open source free software and everybody in the world have access to it. But again, it comes to fourth component, people. If the government officer is trained in QGIS, if he has sufficient time to get training in QGIS, so the answer is definitely not. If it is a collector or deputy collector level officer, वो बोलेगा कि it is time for me, proper time for me to learn QGIS. I just want to visualization of data, that's all. And for that, you cannot mandate me that you install QGIS in my desktop. I will not install QGIS, but still I want all the database. So I will give him one again traditional methodology that I will get a printed PDF maps derived from that all these things, and I will give a thappi of on the collection of maps on his table. So does the collector level or deputy collector level officer has time to see all these individual maps and draw inferences? Definitely not. Again, what can be done? So again, we need to apply one more component for it. And this is naturally a web GIS. So if there is mechanism that we can transform all this desktop data into GIS data, web GIS data. So again, I just told that the technocrats and the engineers are very thirsty animals, and they tried solutions for all the things. So like other things, they also found out the solution for this. So they don't matter. We will have an online server for that. We will host all the database on the online server, and we will show you all these front-end screen, etc., etc. But the officer again sent him back. So I don't have even budget to host the online server. I don't have this what we'll say, but manpower to call for an AMC for that 3 years and all those things. I just want data. That's it. That is my final requirement. I want data. So again, if there is some form that I can make available this data offline, but using web technologies. Okay, this is more interesting. I want to make available data using web technologies, but offline. Like it is like to say, I want to use Google, but without internet connection. Is it possible? Can anybody in the world can use Google search or Google Maps or whatever it is? Forget about Google Maps, Google search, and he don't have connectivity. He's totally offline. He is on Mount Everest. So for Mount Everest, can he use Google search? Definitely not. But engineers are the creatures who deliver solutions that anybody sitting on the Mount Everest can access web technology based GIS datasets. Okay. How it is possible? I will show you. So for that, we developed web GIS sort of things, and we came up with this web GIS. Okay. Now what is our methodology or delivery of data? Now again, I will draw your attention to components of GIS: hardware, software, data, people, methodology. Okay. Now you see yourself as a responsible top government officer, like a collector or deputy collector or ZP person, or whoever it is, concerned higher authority. He has access to hardware. He has a laptop or computer on his desktop. Okay. Software, he don't have access to QGIS. He has access to QGIS, but he don't have time to download QGIS and learn QGIS, and it is not expected from him. Then he cannot be converted into a trained people because he has a lot of many things to work. Then what two remaining options are held with us? That is data and methodology. So data is available with us. But what about the methodology then? So what we did, we packed all the data. We packed all the spatial data into a particular offline WebGIS format. And we just sent him this zip file. Okay, to his PA rather, collector's PA suppose. And it is just a few lines of instructions on how to use this. So please, sir, please find attached to it here with the zip file, etc., etc. The steps to follow. Number 1, unzip this folder. When you unzip this folder, a folder name with this name will be available to you. And step number 2, you just click on this index file, double click on the index file. And all this data, having all this identification and inventory of existing water bodies and WHS in Nasik district will be available on this top authority on its desktop hardware just by unzipping and double clicking the file. That's all. For example, this is the Bagaland WHS. So this is the cluster data. So in this part of the block, there are 31 water bodies and 28 water bodies. For simplicity, I am showing only water bodies. Then again, this water one, I zoom one level. Okay, I zoom one level. This is distribution is like this. Again, I zoom to level, distribution is like this. Again, zoom level, distribution is like this. And these points are the water bodies. Okay. Now this is about one block. Now likewise, I can switch on all the blocks. Okay. And this is available to me of the whole district distribution of water bodies. And that too with a backdrop of Google satellite image. It is not a hybrid, but a Google satellite. And all the availability of all the water bodies. Likewise, we can do with the rest of the structures like farm ponds and other small things, etc., etc., etc. So again, we have to refine our basics of GIS. Now the end user, who is a top officer, what he needs: hardware, his laptop. Okay. Software, no software. Absolutely no GIS software. To view and access this data like Google Maps, like OpenStreetMaps, he don't need at all any GIS software like QGIS. Then third one is hardware, software, people. People, no matter, he is a trained people because he know how to use Firefox or any other web browser. He knows how to unzip the folder. He knows how to double click a file. That's it. Data is all available here. Data is available to him in a very presentable manner. It is available in the clustering clouds. It is available as far as block boundaries are concerned, whereas block names are concerned. On that too, on the backdrop of a Google satellite image. Okay. And methodology, he does not need to care about methodology, what I have used. My job is to identify the methodology by applying which there will be minimum efforts for an end user. And for top officer like a collector, district collector, these are the bare minimum efforts that he gets, that he has to waste to have a fully functional, presentable, viewable geographic information system on his desktop, just unzipping and double clicking a file. This is the power of GIS. Okay. So I will definitely heard a few comments from you on this. I will explain the other parts in the rest of the half an hour, how it is applicable to different, say, your supply chain management sort of things. So may I get your reciprocation in some sort of time, some sort of comments, please?
Please ask your doubts, or please be interactive.
Is it satisfactory and interesting?
Yeah, for me, I think it's a really interesting lecture. I was hearing all the way, so it's really interesting.
Thank you.
Very informative level, with all the aspects covering. So it's very nice lecture.
Okay, thank you.
Participants, please share your comments. Any queries, anything, please be interactive. Right?
I will have a sip of water till then.
also take a break, sir, if you need, like, please take a
Oh,
break.
it's a half an hour remaining. Okay. So I may continue. It's just half an hour remaining. It's 12:20, I think, So it's okay for me.
Sure, please.
Okay. Now let's stop this, and I will come to another part that is properly in line with your this particular session or training program. That's supply chain management. Okay. So I have background of government processes. Not I will definitely say technology, but processes. So supply chain is the process which not only used in the private companies. In private companies, their supply chain management is most of the time, or it is a part of their ERP. Most of the bigger commercial companies have come up with enterprise resource planning systems, and all these supply chain management, logistics, and all these, those are integrated with their existing databases, like customers, their vendors, their suppliers, then their logistic partners, like which carry out material from one point to another point, their warehouses, their sales teams, location of their sales teams. So actually, they have all these integrated database as far as their supply chain management is concerned, and they have altogether different methodology for analysis of that. But as far as GIS is concerned, how we can assist to this mainstream application, their mainstream ERP. So first of all, we can identify the features which they need. And here it is our sentence which I told, that 80% of the data has some special component in it. Helps us a lot. For example, take an example of warehouse. So they may have all the information of warehouses in one Excel file. Okay. About its location, districts, etc., 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 capacity, the parking capacity of vehicles, etc., to which area they consume, how many sales teams are under their team, how many outlets are there under team, how many shops make use of those warehouses, and all that, their own methodology or their own terms, terminology, etc., etc. But as a GIS person, GIS analyst or GIS programmer, we can build all the locations, database of all the locations of those warehouse on the similar lines which have shown in the OpenStreetMap. But there is one big difference. As OpenStreetMap deals with public databases, so a warehouse of a particular company cannot be termed as a public facility system. It is definitely a private facility system for that company or that organizations, whatever it is. But still, as a GIS person, we assist them in building their databases. So now, if we first very basic part of this is to call the respective person, okay, into office, our office. Just open QGIS, just open Google Maps, and just gather his tacit information. We call him as a tacit information, because the information only he knows. In fact, we use this tacit information in our project because only those are the ULB linemen. Those only know from underground pipelines. पानी की pipelines कहाँ से कहाँ जाती है, where is this sewerage pipeline goes, etc. Even municipal engineer doesn't is aware of it. Just they are rely on these linemen. So the end user is very much important in this case. Case. So if we call this person who knows all the location and who is able to find out those location on the Google Maps, Google satellite image, it's very much easier for us to develop a database of all the warehouses. Okay. So we have all the database of all the warehouses, and we have attached the information in Excel file if it is already present with us, or we can create an empty attribute table. We can attach the columns which information we want to have from that warehouse, and we can just the data entry form just I showed last time. or that Gram Panchayat Anganwadi sort of thing. We can just fill up that form in using desktop GIS, and we can acquire or capture all the data for that warehouse. So likewise, we have developed a database of all the vector layer of a warehouse. Then again, in some other systems of supply chain management is the vendors. So if it is, I'm a say a vehicle manufacturing company like a Tata or Bajaj or something, Skoda Motors, etc. So most of the material come from other ancillary industries. Okay, these ancillary industries may be located anywhere in India, but mostly concentrated on the area. For example, in Pune, majority of the ancillary industries, car industries, which assist car industries, are concentrated in this Pune MIDC, Chakar MIDC, this Ranjangaon MIDC, etc., etc. So I can build a database of all these ancillary industries or vendors, which gives me materials to make it finished product of a Skoda car, say, on this production line. I can also capture the location of those automobile vendors, means what we say dealers, automobile dealers. So how can I make use of it? So I can capture all this relevant information. Just I said that warehouses or automobile dealers or our dealers or any other entities which are part of this supply chain management system. Now I can integrate this spatial database with the existing database, and I can see visual reports or visual maps instead of visual reports, which used to be in previous case. For example, I was Skoda dealer, marketing manager of a Skoda cars, and actually from each and every location of a Skoda dealer, I want to know how many cars are available with him of that particular model. So for Skoda Superb, I have say 5 cars. Skoda Rapid, Rapid not there. Slavia, these many cars. Octavia, these many cars, etc., etc. So I want to have information. No doubt, if I have a proper ERP for this, I have this information available with me in this particular prescribed form. But that is also in a Word format or in an Excel format. It will just list out the name of the dealer and car available with him. But it will not add to my knowledge, or I may not get insights from it. Okay. So to get insights from the existing data, I need those on a map. And just I show you that chloroplast map of the percentage irrigation area against total irrigation area. So at one single query, I can show how many cars have not sold from a dealer, and 20% are still remaining with those dealers. I can easily get a list through our ERP system. But if this is shown on the map, so as a manager, it's very useful for me. Likewise, you can have any sort of things. How many customers are there, dealers are there that our payments are yet to receive, or payments receivable, or we have to deliver payments to which vendors we need to deliver payments. So where components comes into picture, the GIS helps us to capture, to show or analyze these where parts. For example, as far as logistics is concerned, so there are GIS applications, GPS-enabled GIS applications, in which they held a GPS instrument into their truck. Like these Ola cabs and Uber cabs have GPS instruments in their cabs. So it's very common to have a GPS instrument mounted to a vehicle like a truck. So, and the live location of the truck is actually can be captured on the maps. Applications, there are widespread applications, and many transport companies also use them. Even now, MSRTC has also started using it. The live location of the bus, live location of the train. It is very prevalent technology. How supply management system can make use of it. For example, I want to load a tonnage of say 2 tons to carry it from place A to place B, and if one more truck has some 400 kg or 600 kg of vacant space with him, so in real time that truck driver can be routed, or I would say rerouted to this location, and he can be told to lift the particular goods from this particular warehouse, say 600 kilos, and drop it to this particular location B, which is en route to you, which is in your own route. So I can make maximum utilization of the vacant capacity of the truck in this case, because I know it's warehouse, I want to deliver this much of goods to this particular location. Otherwise, if the all the trucks are loaded with full capacity, then it will be transferred to schedule will be transferred to next day. But if eventually one or more than one truck has enough sufficient vacant space or available tonnage space with them, then they can be rerouted and immediately lifted in a couple of hours or 4 hours and transported to their destination. So this is also a better use of GIS technology as far as supply chain management is concerned. So there are we can, if you capture in this same manner each and every shopkeeper of their, say, who sells pickles and all those things, or in MFCG industry, what we broadly term that them as FMCG, not MFCG, FMCG industry. So it is very useful for them. Say at a point clicks, they are able to know how many shops are left. They have not even sold 50% of our stock. So on a map, just they will just see the points. So these are the places. Then they can analyze. Okay, this part of the city is not interested in our product. So stop delivering our goods here and concentrate on this particular part. So it's very prevalent way for, or very advanced way of decision support system, which we term them as a decision support system or spatially enabled decision support system. So GIS is effectively used as a analytical system for supply chain management, your own domain. So this is a very short and pointed information about supply chain management, as it is dominated by the ERP system as such, because GIS cannot override or overrule existing system. It is always a helper application or assisting applications in most of the areas. So like supply chain management system also, GIS is not a main system. GIS cannot be termed as a main system, but it is just, I explained the plugin system. So GIS is a plugin to the existing ERP system. If you remove the plugin, if you remove GIS system, then their core GIS system, ERP system is never going to get affected. They will carry on their own day-to-day activities just like before. But if they deploy GIS system as a plugin, which it will enhance their productivity, which will enhance their analytical skills or analytical features, then definitely it will be useful. Just I explained, if you download and install QGIS, QGIS will not do will do only common things for you, but it will not do a lot advanced things for you unless you install the plugins. Likewise, ERP, which they deploy without GIS system, it is a functional system for them. But if we deploy GIS as a plugin system or helper application to that, it will assist or boost their productivity or boost their functionality like a plugin. So GIS can always be plugin or assisting systems in most of the cases, unless there are GIS related projects like our projects, because we represent the core GIS company. So as far as the utility capturing is concerned, underground or subsurface, or remote sensing and deploying all the, digitizing all the databases of all the water bodies and farm ponds and etc. etc. These are the core GIS systems, like the ERP systems in a supply chain management system. But in the rest of the supply chain or other ERP systems, GIS just plays a very important role of a plugin system, because it will get a visually appealing report. Just I showed in the last session that our irrigation pattern sort of thing. It will visually appeal the decision maker to take proper decisions. It will save his very much time, and his analytical skills are boosted. But depending upon the availability of data, again, we may need to develop all these geospatial database from a scratch, because in no public system, nobody will found the existing layer of warehouses or industries or other things. That layer needs to be built from scratch. Most probably that is a point system. Again, you develop the point database system. Okay, from within QGIS software, there are plugins for routing systems. Just we use Google Maps, our Android application of Google Maps for routing, to find the shortest route from going my home to say station or any institution or hospital, etc. And Google tells me the shortest route on the my Android mobile screen in the Google apps. Likewise, there also exist routing applications for OpenStreetMaps specifically. This is a one called as OSM Navigator. You can try yourself. It's very small application, but it's very feature-rich application. OSM Navigator. You may note down that OSM Navigator. So using this OSM Navigator, no, you can have a routing applications to similar to Google Maps, but instead it takes advantage of the open source map APIs that I showed you, key and values, which is not possible with Google Maps. Google Maps have one layer that you can identify petrol pumps and all those things, etc., etc. But here is a vast information available to you, key and value wise. So I just showed you the OSM info example. Like I just put the key amenity and value as a hospital. Likewise, you can browse all the hospitals in that area, area visible in your Android app screen, and you will get all the hospitals highlighted. And in runtime, you can send its KML to some particular thing, some particular person. Okay, so that was some of the topic, but it is possible to build system. Now, if you import all this your logistic or supply chain related database, point database in this particular app, so you can take advantage of the both to identify the location of that particular thing and to find the shortest route between your company to warehouse to distributor to one particular shop or something, sub dealer, etc., etc. So you can make use of the existing hardware, that is your Android application, Android phone. You can make use of existing software, that is an Android app. I just explained OSM Navigator. You can deploy the full data. You can learn yourself to use that app and develop yourself as a people and have your own methodology. Okay, so we have done this methodology. We can develop this data. We are using this already existing data. We are using this app, and using all this, we are finding the shortest route between my warehouse and the sub dealer. So it's very you can try yourself. It's very easy. I will not say easier or easiest, but easy. It's rather easy once you know how you deal with all these application and data. So these are the couple of examples I just illustrated for your own domain, like a supply chain management system. Supply chain management system, as against private companies, is also demanding in disaster management. And as a reputed institution, IIIT, I would not only request you, but I would urge you to develop all these databases for the sake of betterment of a government and the people in their turn. because government, we are dealing with government agencies, say some 20 years, but they don't have capability, and moreover, they don't have time to all for this. This is the one perception that government people are either they are lazy or they just are careless, etc., etc. That might be applied for some section, but as far as top officers are concerned, they really don't have time, and they are already burdened with their own day-to-day activities. Okay, so by some channels or by some things, if IIIT takes this initiative in this particular area or for your state or for particular pilot job, that to deploy supply chain management principles, okay, supply chain management principles in disaster management. This is a very hot topic in which we are also working, because when a disaster happens, okay, all these systems which either which currently company deals for his ERP in supply chain management has to deal with for government agencies. For example, medicines. If there is a disaster like a cyclone or something, so the to maintain the proper supply of medicines to the affected area and help those people is a very headache for government agencies, because they don't have state-of-the-art systems installed or deployed with them, which otherwise private companies have, like ERP and integrated database of GIS to their ERP system. Government lacks all these things. They don't have, as I said, they don't have budgets, they don't have people, they don't have software, they don't have methodology. The most important part, they don't have methodology how to deal with these spatial databases in terms of disaster management system. So we can apply what this is the last day of our training program. Okay, and I am quite confident that you have sufficient knowledge about the supply chain management system as such. So it's a very interesting project for an institution yourself to carry out the supply chain management principles for disaster management. And actually, we are rather safe people. Pune is one of the safest city in the world. We host on a Deccan Plateau, okay. But your East Coast is very prone to disasters. I'm sorry for that, but East Coast is very prone to disasters like cyclones and all those things. This Odisha and Andhra Pradesh and Tamil Nadu are very much prone to, due to nature of the topography and the nature of Bengal, Bengal Sea. So it will be quite useful for your government also. So we'll apply the same principles. Okay. First of all, what is our line of action? What should be our line of action? First, we will capture all the health facilities. So what are those health facilities? Say hospitals. So we'll capture all the hospitals. Now again, I will go to methodology. What methodology should I adopt to capture all the hospital in this particular East Coast area in a 50-kilometer buffer? Okay. I may not, or I don't need to capture all the hospitals as a part of disaster management system of, say, whole Andhra Pradesh or whole Odisha. But a 100 kilometers patch, 100 kilometers buffer area from the eastern coast, is of my area of interest. So my first priority should be to capture all the hospitals in the 100-kilometer buffer area away from the area away from 100 kilometers away from the east coastline. Likewise, then I will capture all the medicine shops. I will capture all the grocery shops. I will shop all the food grain departments and warehouses where food grains are stored. And likewise, which are necessary, I will digitize all the fresh water sources. Okay, because it is also headache to give fresh water to people. But nowadays it is not that priority, because even in the hit area, water bottles are prevalent. In fact, I was a part of a disaster management post-disaster systems in this Andaman earthquake, and the tsunami. Because tsunami did not hit much to Andaman Islands. It hit much of Nicobar Islands. But in Andaman, there was a damage due to earthquakes. In Andaman Islands, damage was mainly due to earthquake, barring Little Andaman Island. And tsunami hit the Nicobar group of islands and the Little Andaman Island. But again, there was a flood of plastic bottles in the eco-sensitive forests of Andaman and Nicobar, both islands. But there was no alternative. So in very short time, in a couple of years, these Andaman Islands and Nicobar Islands were flooded with plastic bottles. So it was also one of the things. But actually, as I said, it is like a hardware. We cannot help in this matter. People just send plastic bottles, water bottles, and it serves the people. Basically, it is a need of an hour. So nobody, even government agencies, don't bother because it is a need of hour to give water in any manner or any way. But again, we can capture the locations from where water will be available to the affected people. So we can capture the facilities from where water is available, medicines are available, food grains are available, fast food items available. Then the utilities like the blankets or other, other things which people lost in the disaster, those are available. We can map the shelters. Okay, we can map all the shelters, which as a disaster preparedness plan, and we can create attribute data and attach as much attributes to that shelter table. What is its capacity? What are its existing facilities available? It is whether it is alongside the road or off the road, whether it is in the jungle or where. Well, actually, we can attach as much information as possible, which is relevant to us. Okay, and we can build several such database of layers that we built in supply chain management system. Because supply of material and to establish proper chain and to maintain that chain is the most daunting task for a government in need of disasters. So we can all the way can build such databases for a disaster preparedness plan as such. And if at all, if government has its own disaster preparedness plan in its place, either you can give this information as a plugin to their existing plan. And my experience tells that they don't have such plugins in place, at least in Maharashtra, plugins with GIS-based system, but actually it can be help them a lot. As far as if we deploy the supply chain management principle to government agencies. So that is all about today's things. Now I will keep last 10 minutes for question and answer sessions. So I would request Dr. Arun, will please encourage your participants to ask me questions.
Thank you very much, Victor, for the kind presentation. It was very good, very nice presentation.
Thank you.
Covered almost all aspects of it. Very practical approach. Thank you very much. And yeah, our participants are all faculties and senior people, so obviously they will be asking questions. Please, if anyone is having any queries, anything, please feel free to discuss, sir. Any practical aspect if you want to ask about, please. He's a person with a lot of experience, obviously.
Yes. And I would request you to ask questions about disaster management, because actually your area is a disaster prone area per se, and such exercises have never carried out for mapping at least. I guess I say this is Chennai floods that Chennai floods woke up as far as GIS-based disaster management systems are concerned. So this is also a need of our college can give these students as a projects or sub-projects to capture all the information, to get databases developed from them actually within your own processes of the colleges. Please.
Yeah, actually, in fact, we have people from all over India, like faculties from different places. So obviously, they will be, different places, different sort of disasters will be there.
Yes.
interested, please, participants, please feel free to ask any queries. Interactive.
Now it's your time, please.
Yeah. any doubts? Please ask. Any problems of interest you want to discuss? Please feel free to do that.
Actually, are there any civil engineering faculties from civil engineering? I hope a couple of questions from civil engineers.
Yeah, I think a few faculties are there from civil engineering as well. Yeah, Krishnakant is asking some doubt. Please, Krishnakant, sir, go ahead.
Because nowadays, for that, sorry, you're a triple IT, no? So, do you only deal with information technology only?
Yeah,
Or there are other branches?
Yeah, we are only on IT, but we have participants from different the faculty
Streams, different streams.
Yeah, we have participants from different institutes.
Yes. Because in the diploma colleges and engineering degree colleges in Maharashtra, no, they have included GIS and QGIS as a part of academics. Their academics.
Actually, there is one suggestion. They are asking, like, can you share the link in the group? I mean, whatever links that you have shown by searching.
Okay. First was the okay. May I send you the mail then later on?
Yeah, sure. You can send me the email.
Yes. There is one more interesting field, and for that I request you to share my screen. Okay, I will not share, but there are lots of YouTube videos available. Very interesting YouTube videos are available. For example, so you just go to Google and YouTube QGIS learning anything. So an absolute beginner's guide to QGIS is 1 hour 10 minutes, this 50 minutes, etc. And there are channels. If you learning channels, so there are a lot of channels. Okay, for example, you will get links from the channel 1 to this GeoDelta Lab. They have their own beginner's guide. Yes, actually, there are so many learning. So many channels and etc. are available.
Sure. Actually, even we have added some materials in the classroom also, QGIS materials under that. I think so.
This Carl Carlson has a very popular channel. He is a cartoon of himself. But if you go to this Carl Carlson QGIS for absolute beginners class, so here is the channel, and it's a host of videos, and it is the most popular. So it covers from absolute beginner to advanced topics, quick tips and all those things. But actually what I would suggest to go with a beginner, and they are likewise linked to next advanced like this. So there are very many. If anybody is interested in watershed development, there are also videos relating to watershed development.
Yeah, I think you can explore it.
Yes.
we have uploaded a few links. And any other question? Yeah, if you have any questions, please feel free to contact us, and I think you can contact Abhay as well.
Yes.
Mind.
Yes, yes.
Okay. Thank you again, sir, for the very informative lecture. It was very nice to hear and follow it thoroughly. I hope all the participants have benefited from the lecture. And,
Okay.
in case of any doubts or any issues, contacting you.
Sure.
That,
So, yes, yes. I thank you, Dr. Arun sir and IIIT CCT for inviting me to deliver this lecture and present my part of knowledge. Now it's up to you people how to utilize it. And actually, I would be happy if there is a reciprocal actions from your side, and just not requesting but asking me. So how to do this, how to do that. So you don't request me, but you ask me. You can ask me, and I would like if you ask me rather than to request me. Okay. Thank you once again.
thank you, sir. Thank you once again. Thank you all for being in this session. Thank you, Abhay, sir.
Thank you. Bye.
And participants, so today we don't have any afternoon session, so we'll wind up this 14th to 18th session, hybrid mode session here. Now from 20th onwards, we will have online session from 4 to 6 p.m. So that will be by the experts. So please note that the expert talk links is different from the current link. So we will be sharing each day link through email and also in the WhatsApp group. So please follow it up. And as I messaged in the group as well as in the classroom, we will have test on 25th. On the 25th. So the last day, we'll be also having well prepared the last day. Also, one more thing is that we will be giving books in this area, in the area of machine learning or GIS to top 20 participants. So please follow up the materials, and also in case of any trouble or any issues, kindly let us know. So today, actually, till now we have covered the basics. How the practical sessions. Now we will be hearing from experts in the coming days, from 20 to 25. Hope all of you are enjoying the session. Thanks once again. And in addition, we also have uploaded practice questions in the classrooms. Please follow up the materials being uploaded in the classroom. In case of any issues, kindly message me directly, or you can message in the group, or email me, or you can even call us. Thanks once again for making it a success. Please attend all the sessions. It's mandatory. Attendance is mandatory, so otherwise we will be helpless to give you certificates. Please attend all the sessions. We will be taking attendance through Google Meet. Through the information provided by the Google Meet. So, thanks to all. Any queries you can ask now as well. Any concerns and queries, let us know. Otherwise, we will wind up the session. If any queries or concerns, you can put it in the chat box. Okay, so we'll wind up the session. Thank you all. So we had a 5-day section, 14 to 18. We had this session. We hope all of you enjoyed it. Thanks to all our speakers for being kind enough in contributing to this, and thanks to all of you for making it a success. Thanks once again. We hope all of you enjoyed it. So please continue participating from 20 onwards. Thank you. Thank you all.
Thank you.
Thank you. Thank you, Abhishek, for the nice comment. Thank you.